Because what you don't know about energy can kill you. Here's Alex Epstein.
Welcome to Power Hour. I'm Alex Epstein. Today, we have a unique guest with a unique perspective on energy, and I don't use the word unique lightly. His name is Adrian Bejan. He is a physicist, specifically a thermodynamicist, so somebody who's an expert in thermodynamics, which relates to the dynamics of heat. And he is world renowned for what is called constructal law. So constructal law is what it's trying to do is it's identifying certain universal dynamics of how the world works. And these are really universal in the sense of they apply to every aspect of the world, from how climate works to how your car works, even to how universities evolve. And so one theme of his work is that one characteristic of his work is he's showing similar dynamics apply in all kinds of different contexts that you wouldn't think they apply. And in his book that I read recently, Freedom and Evolution, you really see this. It's really fascinating. So just to give you a little background on how I discovered Professor Bejan and what I'm excited about, I learned about him through a journal article that was called Why We Want Power. Economics is Physics. And this was shared with me by a listener of mine, and I guess a fan of Professor Bejan's as well, Ian Coville. And so I'll just read you a few quotes from this and comment a little bit, just so you get a sense of where Bejan is coming from and why he and I are very aligned, although we come from very different backgrounds, although he actually teaches at Duke, where I went to school, but I never met him when I was at Duke, and I was in philosophy and computer science, and he was in engineering and physics, so we never crossed paths. Okay, so here are a couple quotes. The design of the flow of power grows in an evolutionary manner, in time, as thicker and more efficient streams that serve, empower, and liberate humanity over greater territories. So he's talking about greater energy use, serving, empowering, and liberating humanity. Or today's focus on efficiency and conservation gives the false impression that the future belongs to burning less fuel, uniformity, and belt tightening, particularly in the advanced countries where most of the power is being generated and consumed. So attacking this idea that we're headed toward using less fuel. Another quote. So far, the focus of energy science has been on the generation of power, not on what happens after. This is something I definitely agree with, that there's just not nearly enough focus on, from my perspective, what is the value of energy. Now, let's go see even further. He's talking about, and this will come up in our conversation today, about how energy inherently impacts environment and how that's a good thing. So here's a quote, the visible result of the consumption of fuel is the movement. Or might be of movement. I might have typed this out incorrectly, but is movement, the rearranging of mass on the horizontal landscape. So it's very, talking about movement is rearranging of mass on the horizontal landscape. So very much talking about impact. Or without fuel consumption, nothing moves, not our stuff and not the stuff of the environment. So as this indicates, and as you'll hear, he really embraces the fact that action, life, movement, progress, all of those inherently impact our environment. And so it's so deeply problematic to talk about not impacting our environment. An example of this concretely that he talks about when he's talking about dams. Without dams, the rainwater slides down the hill anyway. And at best, it sets some debris in motion. It does not move us. In contrast, human ingenuity, technology, power plants intercepts the water as it falls. And thanks to the dam and turbine flow configuration, it extracts power from the falling water. So this is basically the water is going to be going down the hill anyway, and it just gets some random debris in motion. But if we use ingenuity, we can harness that for a good purpose. One fascinating theme of his work is he's just taking a physics perspective, particularly a thermodynamics perspective on everything. So that includes machines, that includes humans, all kinds of living and non-living phenomena. So he quotes like, everything that moves is an engine. Or in terms of economics, quote, economic activity represents the movement of all the streams of a live society. people, goods, information, communications, and everything that flows inside the live human bodies and the running engines that drive this movement. This is the physics domain in which economics belongs. So it's really focused on when we're thinking about economics, there are certain underlying physical factors that are operating, and he finds it very clarifying to understand these factors and not to just have it be it's in everyone's minds. And I think this is actually a fascinating area of inquiry. And I think there are two ways in which you could go wrong in economics, although they both have merit to them. So one, there's the Austrian economics perspective, and I'm a big fan of Austrian economics, but the idea there is that value is subjective, and it can make it seem like, okay, value is just in people's heads and it has nothing to do with physical reality. And that is an important kind of perspective, because ultimately value is all about how people evaluate things. That's what determines the price. But nevertheless, there is a real physical component going on with the creation and consumption of value. Human beings aren't just doing it randomly and arbitrarily. We're ultimately trying to make our lives better. And that involves doing certain kinds of physical things in reality. And I think Bejan's work gets at that. And I find that very clarifying. If you're interested in a thinker who properly integrates the like the mental and the material components of economics, I think Ayn Rand in the essay, What is Capitalism, does the best job of this that I'm aware of. One final quote from him, from Bejan: "We are an evolving human and machine species, which is a flow system immensely bigger and more powerful than the naked human body." So you can probably tell if you know my work at all. I love the idea of machine labor, of human beings producing these machines and the power for these machines that can then produce so much value for us. And just one final quote from his essay, not from him, but I love this quote. This is from Matthew Bolton, who is an early pioneer in energy. He says, "I sell here, sir, what all the world desires to have: power." And power is capitalized, at least in the quote. So I read this article and I thought, wow, this guy I'm really aligned with him. I could learn a lot from him. I think my audience could learn a lot from him. It's fascinating. Often when people have these big integrating ideas, they're often wrong and they're often cranks. So so crank is sort of somebody who is outside the mainstream deservedly, because they have these ideas, but those ideas don't correspond to reality. And so they're justifiably rejected. Now, you can be rejected unjustifiably, which certainly happens. But one interesting thing about Bejan is he's got these very novel ideas, and yet they're not rejected by the mainstream. I mean, maybe they're not accepted as much as he thinks is proper, which makes sense to me, that he should be even more well known. But he is a very elite academic. He's got what's called an H index of 100, which is that shows how much influence you're having over your field. On his website, it talks about him being one of the most 100 published authors in his field in the world. He recently won the Benjamin Franklin Medal. And just to give you a sense of that, this is described by the chairman of Duke as quote, "The Franklin Medal is one of the biggest, oldest, and most coveted honors in science in the United States, and is among the highest prizes to which all scientists can aspire, including those from mathematics and engineering. Take, for examples, Mandelbrot, Tesla, and Edison, who did not receive the Nobel Prize, but were honored with Franklin medals." And then the Franklin description of Bejan was included, quote, "His pioneering interdisciplinary contributions in thermodynamics and convection heat transfer that have improved the performance of engineering systems, and for his constructal theory," that's what I was referring to with constructal law, "which predicts natural design and its evolution in engineering, scientific, and social systems." So that's some background on Bejan, why I was interested in his work, to give you a preview of what we're going to be covering today. And then in the next episode, we had so much to talk about. We decided to divide it up into two interviews. And this is an unusual kind of thing, because it at least gets into more technical issues than we usually do on this show. I thought listeners of Power Hour would enjoy hearing Bejan's unique physics-based perspective on how the world works. He's got a physics-based perspective on the value of energy, the value of environmental impact, and the value of freedom. But I'll note that because he's definitely a theoretician. He's an abstract thinker. He's formulating theories that apply to a wide range of phenomena, and he's invoking concepts from thermodynamics that most listeners, you won't be thinking in terms of those concepts all the time. So there may be points that get a little too technical to follow. I've done my best to try to keep things anchored concretely to where almost anyone could understand it. Um, and I think particularly toward the second half of the episode, we really get it a little bit more concrete. But no matter what, I would recommend listening to the beginning of this, because I asked Professor Bejan about his story, like how he got started. And he just has an amazing story about fleeing communism. And it really shows what a journey he's gone through from being, behind the Iron Curtain to being a leading world scientist. And you can get a sense of how much he understands freedom in such a unique way, but just also emotionally values freedom. And so I found that very moving, and I hope you will too. So, with that, enjoy part one of my interview with Professor Adrian Bejan. All right, I'm joined now by Professor Adrian Bejan of Duke University. Professor Bejan, welcome to Power Hour.
Thank you for inviting me to speak to you and your audience.
Great to have you. So if you'll indulge me, I just want to tell about a minute story to the audience about how I became familiar with your work, or rather what resonated, because I am, I don't find a lot of people who are oriented in the same way as I am about energy and freedom. And I least expect it from university professors in my experience. And then I read this book that's recommended to me about freedom and evolution. And I just want to read a quote from this. So readers, I mean, anyone listening to this show knows that, I have a very deep love of human freedom, and then a very deep belief that human energy production / conversion is fundamental to human flourishing, including human progress. And I have deep objections to the modern egalitarian movement, and certainly the modern, what I call anti-impact movement, that says that we should have no impact on our environment. And so there's just this quote. Well, so one is, he says, the Homo species that rules the world now and in the near future is the human and machine species. And that just resonates with me so much, because I'm so focused on how machine labor, machine power improve human life. And then check this out. You say, in advanced societies today, some are championing equality in the environment with nostalgic references to the equality and respect for the environment that seem to characterize the poorest living groups on the globe. And then you end with, the physical reality is that both features, lack of hierarchy and lack of environmental impact, belong to populations with little movement, grave poverty, hunger, and short lives. So this is not something that most of my professors at Duke would say. So I found it very refreshing. And I guess the first thing I would just want to ask is, I mean, you're saying this, and you're very well known as an innovator in the field. You're not some obscure crank at all. I mean, you're a leader in your field. And so I'm just so interested in your origin story. And you describe yourself as, in your book, as a veritable nobody from nowhere behind the Iron Curtain. So I'm just curious, what in your early life led you, let's just start out with, to come to the US to study science. And then I'm curious later about your interest in freedom and energy.
Well, yes, I was born in Romania in 1948, and that was a baby boom right after the war. I grew up among the ruins because my city had been bombed both by the Soviets and then the Germans in retreat in the ruins. And I grew up in the 50s and the 60s during the most murderous period of communism in all over Eastern Europe. And so that was obviously my formative school. Communism is not a sound bite. I think if you're interested, I would talk to you for more than an hour about it. But the bottom line is that my parents were intellectuals, so veterinarian, my father, and my father a pharmacist. They were educated in the free Romania that preceded the war, They had nothing to do with totalitarianism of either color, brown or red. They want to be left alone, and obviously they refused to join the party. And so I saw, well, basically they were both imprisoned, meaning disappearing in broad daylight, because arrests were not happening under communism, Alex. People were disappearing. It was a designed mechanism of terror. So this is the way I grew up, and obviously I was angry about what was going on, and I was actually challenged to to grow up in a way that would make me immune or vaccinated against this sort of treatment. And so the solution was, in fact, the whole street was reacting the way I was reacting. I'm talking about my pals, the boys with whom I was playing, were very good in school. Number one, that meant if we had the inclination toward the mathematics, we went for it. We were very good in sports. I played all sports, and then I focused on basketball, and I rose to the highest level. And I was very good. My father discovered I was very good at making drawings. So visual arts, expressing myself visually, which means in a permanent way, because even today I have drawings from back then. This was also relatively unusual, but the most unusual thing is that at age 20, I was good at three things, and in basketball at the national level, frankly, everybody who had a chance to defect took that chance. The escaping from communism was a common, I would say, wish. It happened rarely because there were no passports. There was no way to leave the country. It's not like Syrians invading Europe. I mean, from communism, you could not leave unless you're lucky to have a relative somewhere to save you. And so that was the attitude. There was nothing unusual about my generation in this desire to get away from it, okay? To get away from it. It was so wrong-headed, so upside down, so unlike the people we saw coming, to the Black Sea beaches from West Germany and other cold countries. They were happy. They were well dressed. They drove cars. They were basically as European as anybody, but they were very different, meaning they were happy. And this difference was precisely what was being described in our home. In our home, the story was that before communism, Romania was the same way, obviously, because Romania had an immigration problem. People are trying to enter Romania, not to flee Romania before the war. So that was the education. There are some cliques that again, many of them I would share with you later if you're curious. But as it happened in 1968, this Prague Spring took place, and for reasons still researched by historians, the communist regime of Romania sided with Dubček and engaged in a few steps of liberalization. That's the summer of '68. So one of them was a national contest for scholarships to go study in the West. That was a mathematics contest, which I won. I think I'm sure I did it perfectly. And the prize for winning was one application form to a university I never heard of. Actually, I knew because of the moonshots, but I had no idea what it really meant. MIT. It was a folded page meaning a piece of paper with 5 sides to it. It was green, and I filled it out. And then I had to wait 6 months to be evaluated. So that's how I was admitted to MIT as an undergraduate. And I arrived there in February 9th, 1969. and then I got all my degrees at MIT. Now I credit all these things: the math, the basketball. By the way, basketball was a liberating track for me because it meant that I was excused from absolutely any involvement in political meetings, parades, all sorts of bowing and scraping that the kids of my age were forced to go through. I was excused because I was practicing at night every day. At night, the arena was available for our team. We had a top team in the country, and so that was the origin. Plus, basketball, as I look at my career, is where I learned my how to work. Not only efficiently, but in a way that I don't kill myself, meaning with a program, with balance, with punctuality and respect for my teammates, in this case, my correspondents. You, for example, I responded to you. There's this thing that most young men learn by being in the army, but obviously not everybody goes to the army anymore. So the fallback mechanism for raising young men is athleticism or athletics. I went through that, and that benefited me greatly in my work. So at MIT, now to end this story of great fortune, I was in fact very hungry. I had very little money. My stipend was extremely what do you call it, Spartan, to the point that I was the only student, the only guy from exotic Eastern Europe in my dormitory. Nobody like me. So all my pals were Americans, and they taught me English. They taught me slang. We played great basketball together, but they also took me with them to have 4 student jobs on campus so that I would feed myself. You get it? I had 4. Okay, great university. So one of them happened to be essentially the helper to a janitor in the basement laboratory of the cryogenic, the place where they liquefy air into nitrogen and oxygen, things like that, for the physics labs. And the head of the laboratory happened to be the professor who was teaching me at that time the course on thermodynamics. Keyword, actually 2 words, thermo and dynamics. And I love the subject. This professor, Joseph Smith Jr., loved me, and he adopted me. I became, later, after I got my bachelor's degree, I became his graduate student for my master's degree and PhD. And that is how I became a thermodynamicist. It was this amazing luck. And of course, I was very serious about thermodynamics, but I could have been serious in my solitude, you see. But that wasn't the case. I was, in fact, embraced and brought up and brought along, and he made me somebody in this particular domain. I did not follow his direction in the field, but the point is that I was very fortunate. But this is very important for the topic of today, also for the subject that animates your activity. Thermodynamics is the physics of power. Power from fire. Thermo comes from therme in Greek, which means heating. The heating comes from fire, and dynamics from dynamis, with back end originally it meant power. The what causes action to take place. Now thermodynamics is assigned to the concept of force in physics. Well, that's not too far from power. The point is that without fire, there's nothing. There's no movement because the power is needed by absolutely everything that is in order to move. The movement destroys the power. In fact, the very first book that in fact, this is before thermodynamics, but the very first book that essentially said it all was by Sadi Carnot, The Motive Power of Fire. That was the title of the book. It's not about the heating, it's about fire, and it's about motive, which means movement, you see. So that's the end of the enigma of what nature is or what life is. Well, life obviously is movement, and it happens everywhere, this movement, regardless of whether it is bio or non-bio. You have, of course, the movement of the animal kind that comes from the so-called fire in the belly, which actually comes from the free energy, or there's some other words such as exergy, or available energy in the food. All right, that's one. Or these other things that move, say the water in the river basin is driven by the power that comes from the gravitational potential energy of the rainwater on the hilltops. So yes, these entities, objects that we're observing are different, but what is the same is the fact that the movement is driven by an energy source. Let's use common language, and that movement actually dissipates the power that drove it. At the end of the movement, there is no more power. It's all gone like this, rubbing two sticks, which is called irreversibility in thermodynamics. So the oneness of nature is screened from the rooftops by thermodynamics. Thermodynamics speaks of this. Here is power, here's movement, here's the dissipation of this movement into, obviously, heat dumped to the ambient, meaning that the fire that was burning over here by itself in the forest before humans adopted fire, that fire dumping all of its heating in the ambient. Now, because of contrivances, including animals, which are natural contrivances or natural trucks, because of these moving things, including rivers and deltas, that power, which came from a fire, from a source, that power created movement. The movement dissipated the power, and poof, at the end, all the heating from the fire went into the atmosphere as it was going before there were systems in motion and other things, like on the moon, for example. On the moon, you have heating from the sun, bouncing, meaning striking the moon and then bouncing 100% into the cold space. It's the same here on Earth, except that because of things that are endowed with configurations that morph freely, there's movement from the river water to the animal life, and in the end it's the same thing. But on Earth, there's movement or constant reshaping of the Earth's surface, geological eras, or on shorter time scale, today being different than yesterday. All these things appear to be, how should I say, complicated, were complex, were diverse, but the big picture is in fact only one. And
so wait, can I jump in for 1 second? I found this. So in your book, Freedom and Evolution, which I really enjoyed. Yeah. I mean, one of the themes I think is just that there are these phenomena that we might associate with one area of life are much more universal. So if we take what you're talking about right now, I think with the dynamics you're talking about, most of us might be most familiar with our car engine. So for example, our car burns gasoline, and then that generates heat and pressure, and that moves the wheels of the engine. But then we hear that, first of all, we hear that, well, a lot of the energy in the gasoline doesn't even get to the wheels. A lot of it just dissipates, but then the rest of it ultimately dissipates once it's gotten to the wheels. And that what I take from your work is that everything has this kind of like the engine powers something, but then that is in effect a brake and the energy dissipates. So you need constant energy to power everything in nature, any movement, whether it's living or non-living.
That description is correct. It's nobody's fault that only a fraction of the let's say heating from that fire in the combustion chamber becomes mechanical power, work against the wheels, or for that matter against the road. That is thermodynamics. A power plant that converts heating into working, according to Study Carnot, cannot have an efficiency greater than a particular value, meaning that only a fraction of the so-called heating value of the fuel becomes work that does the pushing. That's thermodynamics. What you said about the car can be translated into a zoologist's language. The animal is the same sort of thing. What is automobile to you and all engineers is animal to the biologist. There is food ingested. This thing is designed, obviously, naturally. The animal design is an amazing vehicle, and the vehicle moves. And incidentally, I'm now getting to one of your introductory words. Movement, by definition, Alex, means getting the environment out of the way. That's what it is. It means relative motion means you go swimming. Okay, you swim by getting the water out of your way. You walk through the thicket by pushing the weeds or the canes out of your way. Otherwise, you end up dying by hitting the tree trunks. So movement is synonymous with having impact on the environment, on your immediate environment. Life means impact. Life means movement, and movement means impact. So all this thing about eliminating environmental impact is not only against life. It's just the eliminating will not happen, because nobody is going to opt for death as opposed to life. I come back to Thermodynamics once again, which is a very thin book with very few words. In Thermodynamics, from the beginning, the concept of death was written down. It's so obvious. The dead state is the condition of an object where nothing moves, nothing flows, nothing changes. The shape of the object is not changing, meaning zero feet, among other things, but nothing moves. Well, the antonym of that, you can, turn your English inside out, is, movement, freedom to change, freedom to be deformed, obviously freedom to be thrown or caught. That is the antonym of death is life. So the life state is everything, is the condition of everything you know, everything you look at, everything that's inside of you, inside of your room, inside of your society, inside of history book. In your history book, if you are into history the way I am, you see you see movement. Those wonderful drawings from, say, antiquity and everything else, the chariots, the building of the temples, the pyramids, of course. I mean, the castles, ramparts, all these things. These images may be still or static on your page, but they're the result or the snapshots of movies of movement. And again, in the 50s, when these CinemaScope pictures appeared in color and everything, recreating the stories of antiquity, you saw the moving story of what had led to these edifices. Edifices is one thing, but from movie to movie, from era to era, from antiquity to Napoleon, you saw the evolution of how to move things, or how to build things, or how to organize things, the shape of the army from the Roman, battle stand to, say, Napoleon, and of course, all the way to the 20th century. So you get a feel for the fact that evolution, Alex, has been around forever, and it's a much bigger scale than the salamander or some other small thing that the evolution of which you cannot observe in real time. And so from this point of observation, you acquire the power of enjoying simplicity, or simplicity in the good sense. You're not wasting your time on trying to get out of, you're lost in the forest. No, you're not. You're actually above the forest, and you see oneness. You see no problem. You predict the future. You predict the future, like this thing about environmental impact, or some other slogans all of us hear these days regarding energy, or the future of the planet, the future of society. All these things are easier to understand and easier to predict if you know thermodynamics.
So let me ask about, and I know it's going to be hard to answer pretty quickly, but I think it'd be very valuable for people to understand at least a little bit of the story of constructal law, which is what you're most known for, including, I think it's important for people to know already how influential this has been.
I don't know. Look, influential. That's for others to comment on. But especially as the concept or the field matures, this wasn't a plan. This constructal law. It was an accident. But before I get to it, I meant to put an even better paint on this comment regarding the environment and the impact on the environment.
Okay.
The animal, Alex, the animal is impacting its environment all the time. It's called niche construction. The animal, the bird makes the nest. The bear makes the den. The cat basically meows at my door to be taken in. My house becomes my house becomes a niche of the cat. The animals have been engaging in niche construction forever. I watch these nature movies, birds breaking nuts with little rocks. You see, they use the environment. They actually move things. They rearrange the stones. That's impact on the environment in order to live more easily. So the fact that I am building a fence around my house, or I am paving my street, or I'm doing these things, I'm no different than all the other animals around me. So environmental impact is in fact studied and recognized and admired in biology in the sort of field called niche construction. So this thing with the power from fire and movement and all the way to the civilization of today, the name for that is the human niche construction. Nothing different, nothing new, and all of it nature. You see.
Well, let me say one thing
yeah.
about that, because I just want to say it's very unusual for a scientist today, unfortunately, to have that perspective. And so I'll give you the perspective. I mean, I think of it as if there were Martians and they observed us, they'd think, oh, they build the best nests, like of humans, like we're sort of the best at niche construction in terms of the most powerful. But if you take even an eminent scientist like Stephen Hawking, he has a book with his daughter, and it's all about it's a children's book, and they say, oh, if there were Martians and they saw us, they'd say, oh, what a mess they made of it. Everyone would be so embarrassed by us and ashamed of it. And this idea that, oh, human impact is bad, and that's the exact opposite of how I think of it. But it's so rampant to think, oh, bear impact is good, beaver impact is good, bird impact is good, but human impact is bad.
Well, clearly, I'm not a reader, frankly, for my own good. So I don't know this book, but it sounds like, that's taking sides before you even start writing. Who is to know what the Martian thinks? Okay. Who is to know the point of view of that Martian observer? Meaning, who is to know how the Martian differentiates between organized and messy? I have no idea. What I know is that if you really want to get down this path of judging, this is called being judgmental, judging animals that lived on Earth, yes, I think dinosaurs committed large-scale savagery wherever they lived, and yes, they had a lot to do with the geological era of their time. They're still discovering the winners and the losers of that. The fossils. They're discovering them in those graves. That they're digging up. So the fact that people are changing the face of the earth, they've been doing it for a long time, is no different. This is the human geological age with our dumps, for garbage and recycling. This is what's going on. And by the way, we can get into how much longer this will go on if you want, but that's the view that makes me feel very comfortable with predicting that the future is going to be the same as it ever was. Okay, that's no matter what the cries of I don't know, disaster where the sky is falling, or scary predictions.
Now I want you to talk about that, because there's so much to talk about. But because obviously the one that's coming out of academia is that our impact on climate is going to be so catastrophic that you have 50% of adults surveyed thinking the human race is going to be extinct in the next 50 years due to climate.
Right.
So I'm curious your take on all of that.
Let's treat that subject, but I owe you a very quick answer to the constructal law.
Okay.
What it is and how it happened. All right. So I got my PhD in 1975 and started my career in thermodynamics. There are basically two ideas. The one is the first law, and the other one is the second law. The first law is the law of so-called energy conservation. It used to be called, in mechanics, what goes up must come down. So that's energy conservation. If you rub two sticks, the work that you do on the sticks becomes 100% heat imparted to the sticks. So that's the first law. The second law is the universal observation that everything that flows one way from high to low, heat from hot to cold, water in your pipe from high pressure to low pressure, water from the top of the hill to the valley. So that's a phenomenon called irreversibility. One phenomenon has one law. The phenomenon in the first law is the going up eventually becomes coming down. That means energy conservation. So that's one phenomenon, one law. Irreversibility is the second phenomenon. The name for that is the second law. There are many, there's now a Tower of Babel about the second law. It is to be avoided. The original observation that there is a universal observation called irreversibility is what the second law is. This is what Clausius wrote 150 years ago, and it's very useful for teachers and students to stick to that or begin with that so that they know what the idea was. The point is that thermodynamics, which is the science of, as I said, the power from fire, is about these two ideas, and these two ideas say absolutely nothing about the configuration in which the movement is happening, in which these flows from high to low are existing. Nothing about the configuration. But so here's the click. That was about 25 years ago. But even though these two ideas take half a page to state and to perhaps state 3 times each, the book is thick. The book of thermodynamics is full of drawings of obviously contrivances that obey these two laws, but the drawings have history to them, from the steam engines of Newcomen and James Watt to the, of course, going through locomotives to rockets and turboprops and some other things today in the modern era. And so it occurred to me, I said, thermodynamics is, I'm teaching my students about the evolution of designs. And there's nothing in the first 2 laws that orders the both nature and thinker to evolve the design. So that was the click, because clearly evolution is what thermodynamics is about, and nature itself is all about evolution. It's not just biology, and but I hear the word evolution in obviously geophysics, the evolution of the river basins, the continental drift, the avalanches, the rock slides, the mudslides, obviously the snowflake itself is a evolutionary design. The winds, the whatever atmospheric circulation, all these, and you see them, by the way, on the weather channel. You see this. There's a convulsion after convulsion after convulsion. All these things are doing their best. That is called turbulence. Their best to move through their fellow, spectators in the stadium, to elbow their way through more and more easily. So that's evolution everywhere, and it was not covered in the book on thermodynamics. My drawings, the classical drawings of the book had no right to be in that book according to the laws of thermodynamics. So I said, well, in this case, the fact that the occurrence of all these morphing designs is so universal, it means that this universal phenomenon can be summarized with its own law. And so I wrote down this statement. Actually, I thought about the statement very seriously, because I did not want the statement to sound as if I was a biologist or a geophysicist or a builder of piping systems for some submarine. I wanted the statement to be non-denominational. So I said that for a flow system to persist in time, flow system persisting in time means to live in physics. It must evolve with freedom, so that it provides greater access to what flows. Period. And you can substitute your own words in that statement: fluid flow, heat flow, pedestrian flow in the subway station, whatever you want. And then you get and then you discover, yes, all sorts of flow system architectures, all the way to the design of the pedestrian movement in the subway station. You predict the evolution of those extremely natural and useful flow architectures. You predict the future of essentially of everything, but future on a large scale. I'm not predicting what's going to happen tomorrow. I'm actually predicting what will be in this book of history that I did not read yet. Meaning, I go back and I have a good time doing this. I read books of the history of art, for example, and I see an evolutionary design according to the constructal, the history of written language. How's that? Meaning alphabet from here to here, all the way to today. Of course, the history of motion pictures and history of warfare. All these things are in accord with what I just stated, except that all of them are predictable in retrospect. Well, if that coincidence is so all over the place, then it means that the same statement allows me to fast forward my predictive power into the future, and feel very confident, or in this case, optimistic about the future of all of us. So, if you want to talk about the future of the planet, let's do that.
Okay, let's hear it.
The people are not stupid. That's the good news. And the best of them are the ones who will be born tomorrow. In other words, at all its stages of development, and the world, you know very well, has gone through a lot of big mistakes, and it has recovered from those because, luckily, there were people, meaning minds that saw a better way, or saw the solution, or saw how to prevent even worse disasters. And so I'm very confident if you, and again, the evolution of technology is full of these examples. My favorite, in fact, is part of thermodynamics, the history of thermodynamics. In the mid 1800s, when the steam locomotive was the invention that shaped the world, you know, industrial revolution was that, with steam power. Railroads invaded the landscape. They were atrocious from the point of view of people who are living based on agriculture. Trains were killing livestock. The railroads obviously eliminated a lot of the living space of domestic and wildlife. They killed people at railroad crossings. So there was this, I think now, typical conflict between the good aspect of the new technology and the bad one. Okay, and it took decades for, as I say, the newly born smart people to come up with a better and better design of railroads, to have ramps at the crossings. Much more, and now more recently we have underpasses, overpasses, and a much better peace between the train traffic and truck traffic, and obviously diminishing pedestrian traffic. Now you have the air traffic, incidentally, at a much higher level of perfection than it used to be when I was, say, 50 years ago or earlier. Air traffic accidents were common. Now they're extremely rare. Even though, never mind the pandemic, even though these days the whole world is moving at a rate obviously never seen before. And the point of my little story is that every new technology has it's like a knife with two sharp edges. One is useful, the other one is or can be dangerous. At the end of the war, it was nuclear power. You know that story. And now, thank God, the nuclear power has been not only harnessed, but the disastrous aspect of it has been kept in check because of smart people coming around and coming along and protecting everybody else from complete destruction. And that, of course, brings me to these other concerns that I read about in the press. I'm very confident that when I hope it's not going to happen this way, but when the knife hits the bone, then people say enough of this. Except that I haven't seen anybody reacting that way, at least not yet, because clearly everybody wants to live. And I come back to the definition of life, as I'm sure you've read in my book. There's an undeniable relationship between say the wealth of a group and the rate at which that group is burning fuel. Okay, so wealth in my book is measured as GNP, is in a one-to-one relationship with the rate at which that group consumes fuel. Well, it consumes fuel in order to move things. So movement, which means life, is synonymous with wealth. Wealth that's being spent annually. This GDP is money spent. So that's the reality that says that if people obviously everybody prefers wealth and prefers life, that means everybody prefers obviously movement, which means that perhaps unwittingly nobody prefers to cut down on burning fuel. Nobody, and that's been the record. I mean, absolutely nobody. And so that's the driving force of civilization, not only today but forever. By the same token, you go back to animal migration and everything else. Animals that find themselves unable to graze on this particular piece of land, they move. They move in order to continue to graze elsewhere. This is life. And if you want to not you, but some people want to engage in science fiction, it's of course interesting to imagine what will happen if, for example, a certain commodity disappears completely, or another thing disappears, and all these other things. This discussion needs to keep going. and but the society as a whole will do something about it, meaning a city government here or a country over here will do something about it only when the danger against life becomes not only obvious but unbearable.
But do you think that's actually going to happen? That there's going to be unbearable danger to
No,
life?
I don't think it is going to happen. In fact, I promised you this answer, or maybe I promised to myself to tell you this answer earlier. Look, the reason humanity is doing so much reshaping of the Earth's surface is very, very simple. It's the Industrial Revolution. Quite naturally, the human animal discovered a much more fertile area on which to graze. And that area is called, you call it fossil fuel, that's okay, or some other fuels, because people had come up, smart people, from obviously capable mothers, came up with this idea of a power from fire. Power from fire. So the jump in movement, in everything that's known and connected with wealth, all the way to the steep jump in the world population, all these things are the result of the Industrial Revolution, which means, again, thermodynamics, movement driven by fire. Okay? So, but it's not that this movement is not so big because we have so much fuel. This movement compared with the movement that existed previously because of domesticated animals pulling carriages, this movement is much more intense because the contrivance, in this case, the automobile or the locomotive, whatever, the airplane is a much better horse. Okay? So, but just like the movement facilitated by domesticated animals being bigger than what was before domesticated animals, this new movement, which is now kind of passé composé, the so-called machine-driven vehicle driven by power from fossil fuel or some other fuels. I don't care about the origin of the fuel. The fact is that it's power from fire. This other way will be around the way you see it, and this will get us into the diminishing returns now or maybe later, but it will not be creating another stepwise jump in the movement on Earth. Every stepwise jump in human presence, moving, which means changing the Earth's surface, is due to a technological change, is due to a new species of mechanical animal, human and machine species. In our case, the people in their vehicles, as opposed to the people riding horses or in carriages. And so this little story is about the fact that we're now in a holding pattern, and we see the holding pattern in many ways. Some of this is illustrated in my most recent books. The number of miles driven by all the vehicles in the U.S. has reached a plateau. The world population is reaching a plateau. That plateau is predicted to be reached in the year 250. That's a prediction from the United Nations. So never mind population explosion. It's about population reaching its the equilibrium that corresponds to machine power. Okay, so unless there's another way to move stuff, another way much more, let's call it succulent than what we have these days, the future is very clear. It is the future of what happened in, say, Western Europe, say Belgium, where the whole place is vascularized with power generation and traffic and trains and trucks and airplanes, and very, very little growth in the GDP from year to year. That sort of advanced life will spread more and more over the globe. It will be a good thing for because a lot of the globe is still in deep poverty or unaffected, not touched by this movement that we are now discussing. In other words, it's not the end of the world in any way. There's a lot of change to be made, change in a good direction, and the reason why this is in fact a promising future is that is another empirical fact. If you look at I'm coming back to the image of smart children being born, and that's the good news. If you look at the distribution of countries in these two dimensions of, let's see how I draw this for you to read it this way. On the vertical is the wealth. On the horizontal, in this direction is the burning of fuel. Then on the bisector, in this direction, you have the distribution of countries. At the very top, leading the peloton of the bicyclists are the most advanced countries. You know them. Everybody: Switzerland, the U.S., Germany, France, England, all that. Okay, and then at the very bottom, so many that there's no room for you to write the names of these dots here in the those that are trailing the peloton. And the fact is that the voices and the thinking and the writing and the inventing that is occurring in this group of people, occurring for the purpose of saving the world, is happening in these top countries, in the top universities of the top countries. Therefore, if you really want to empower the world to save itself, then it stands to reason that you should do a much better job of making the population from this other end travel not only upward but faster to catch up with the top of this distribution, and contribute not only to concerns about the future of humanity, but solutions to that better future. In other words, once again, if you're interested in saving the world, then do more of what the population that of course is wealthier but consumes more power is doing. It is these countries that worry about saving the environment, that obviously do a lot of technology evolution to do things more efficiently, more safely, more humanely, more altruistically is going on. All that is going on in the advanced societies, and yes, and you cannot have enough of that good thing. And so, one answer, as I just said, is to empower those, meaning to empower those who are currently not movers and shakers, meaning moving and being wealthy, empowering those to become more and more like us. Not through handouts. I'm talking about through connecting them to the big game, education, and a few other things like that. Yeah, and more freedom. Obviously, we haven't gotten into that subject really yet.
Yeah, well, we got a lot to cover. We're fortunately doing another one of these, but let me ask one last one as we wrap up this hour. I just want to, excuse me, play devil's advocate. So I agree with you totally, everything you said. But if we take some of the colleagues maybe at the Nicholas School, the environment, or a lot of people I've debated, they would say, well, if you empower, you give these people freedom and education, it's what's going to happen is what's happening in China. They're going to consume, for the near term at least, more fossil fuels. And then the view is, oh, the earth is going to heat up so much and sea levels are going to rise and storms are going to get bad and drought is going to happen and the earth is going to be unlivable in the next several decades. So how do you respond to that?
How? You have to restrain me. Don't give me China as an example of freedom. The example that
well, forget the freedom, but I mean, you could take Singapore or somewhere else. They're going to use more fuel.
Sure. Let me tell you, the example that fits in this discussion is what happened to Central and Eastern Europe when the Iron Curtain fell. Yes, the highly advanced West, not just Western Europe, but America and Japan and all these moved and in order to fill the vacuum. And they brought industry, they brought roads, they brought, better railroads and of course air traffic. And with that, they brought the cleaning of the environment. They brought laws of protecting the environment. The place was a mess. It was a cesspool from communism because nobody owned anything. Nobody cared about, picking up after themselves. The Danube was, again, horrible. You had to be crazy to be fishing in it. And so that is the good hand of advancement. The living space, this niche, becomes better, and it becomes better for everybody. Now people are going. These people who love to see wildlife are all over the Carpathians because they are worth visiting. So that's the example. Now what's going on in China is something quite different. That is a one-party state with a particular plan, and the plan of that party, as it was during the Great Leap Forward, was to make China a global power by design, and that means building so many power plants per month and doing all sorts of things step by step. Without exhibiting the same behavior or the same concerns as a society. Say, pick any country you want in Eastern Europe, where they have discussion going on all the time about what to do and whether what they're doing is enough or too much. See, the give and take that we take for granted in a free society is not distributed uniformly on the globe. And it's not only China. I mean, there's a whole list of these places that are not I would say not helping in the direction that
Okay, so let me refine it. So okay, they might, again, with the devil's advocate, they might say, okay, well, yes, the free societies are cleaner, they have cleaner local environments. China has a lot of their dirtiness is related to the one party rule, but they'll say, well, whether you're talking about the free countries or the non-free countries, when they're burning fossil fuel, they're adding CO2 to the global atmosphere, and isn't that going to ruin the world for everybody, and we're not going to be able to adapt? So what do you think about that?
Well, clearly, if we reach that stage once again, once again, the good old USA and UK and Germany and very few other such countries will come and save the world. You look at China. Most of the debris in the Pacific Ocean comes through Chinese rivers, also from India, but the most of it comes from mainland China. All the plastic that's floating and gyrating in the Pacific is from them. And who's cleaning up? Who's cleaning up? A bunch of, very few from these countries that I keep mentioning, from the top of the peloton. They're doing the cleaning up. And so, yes, if we ever reach that stage, there will be an industry of how to save the world, just as there is not a technology, but an industry actually of how to save the world. That's already in progress now with what's going on with the plastic floating in the Pacific and many other such places. I don't think that the topic is novel, really. The topic is not novel. The world as a whole is walking, yes, a fine line between getting through or hitting the wall. That's the evolutionary path of anything that inhabits the world, and all it takes is yes, from year to year, a better, like with the airplanes, a better guidance system, and it will happen. It happens naturally because people are smart and people want to live, and people, meaning, no, they just have this innate desire to live better, more safely, and for their sake, but also for the sake of their immediate relatives.
All right. Well, we're going to have to stop there this time since we're over our hour, but I just want to make sure everyone knows about the book. So the most recent book is Freedom and Evolution, and then you can check out Professor Bejan's other books. I'm sure you can go to Amazon. I'll just give you 1 minute if you want to say anything in conclusion for today, and then we're planning on having another discussion as well.
Well, in conclusion, first of all, if and when we talk again, you should tell me not to talk too much, because I'm afraid that I spoke too much. But I think very important is the first of all the concept of freedom, which unfortunately is the F word on campus. People are afraid to talk about it. Is very important. Number two, there are political implications to this discussion of evolution in nature. Definitely, because politics is about design change at the societal level, and nature, of course, is all about design change. And we know from every lesson in the book that anyone who is trying to oppose nature or violate the laws of nature is destined to lose. So it's important to know the rules of this game called nature and go with the flow for your own benefit and also for the benefit of the surroundings as well. So that's the way I would prepare myself for the next discussion.
Okay, and next time I want to very much center around freedom and then the implications of that. So Thanks so much for joining me, and I look forward to our next conversation.
Thank you, Alex. All the best.
Thanks again to Adrian Bejan for joining me on the show. Looking forward to our interview next week. I would definitely recommend checking out his book, Freedom and Evolution. It's got just so many fascinating things, and I go through these books in Kindle often, and so I like to copy and paste. And copying and pasting. There's just so much material that I took. And he's just the kind of guy, he's an independent thinker, and he has insights on every kind of thing. And it's one of my favorite parts of the book is just like, he'll have a comment here about Wikipedia, and he'll have a comment here about different kinds of academic associations. And some of them I want to ask him about next week, but you'll see he's just got a lot of these fascinating insights in addition to this broad perspective. One of the fascinating things, I won't ruin it for you, but he has a really good explanation of why different kinds of races and ethnic groups dominate certain sports. And it's like so simple, and it's the opposite of racism. But it's just fascinating. And you can see how his way of thinking and understanding the world really does illuminate a lot. So Freedom and Evolution, that is his most recent work. And I know it integrates a lot of his work. So looking forward to the next interview with Professor Bejan. Let's do some housekeeping. As always, if you have any questions, comments, love mail, or hate mail, email me at alex@alexepstein.com. For the latest energy talking points, I've been adding more to energytalkingpoints.com. And I've been mentioning in the past couple of weeks, I have a new service that's free to elected officials and their staff from the US House, the US Senate, and governor's offices. So easy way to refer people to that. All they have to do is go to energytalkingpointsondemand.com. That's energytalkingpointsondemand.com. So if you know anyone from, again, US House, US Senate, or state, obviously governor's offices, you just tell them to go to energytalkingpointsondemand.com. They'll enter in their information. If their information is truthful, if they are a member of those offices, they'll get in the group. And we're having these Monday calls every Monday where I'm sharing the latest messaging. And also we're discussing the messaging challenges, and then different participants are asking or requesting different kinds of messaging. And we've been, I think, doing a really good job at getting people new messaging every week to meet their needs. So far, the feedback is great. We've had about 24 offices participate, but I would like to have more like 8 or 9 or even 10 dozen offices. So refer people to energytalkingpointsondemand.com if they are in those offices. Otherwise, refer them to energytalkingpoints.com, or if they want to receive my resources, go to alexepsteinlist.com. Let's see, anything else as we are winding up the year? I have my book contract is still not officially signed. So the public announcement hasn't been made about the title. Sorry about that. It's coming very, very soon. There are no snags in the process. We're still full steam ahead. I'm finishing up the thing. It's going really well. Really happy with it. I guess that's a good time to remind people of, if you want to support our research and development efforts and our promotional efforts here at the Center for Industrial Progress, including the new fossil fuels book, including some of the energy talking points work, you can become an accelerator at industrialprogress.com/accelerate. One final thing, I've mentioned this before. I know it only applies to a small minority of people, but I did get some good interest in it, so I'll mention it again. If you have a family foundation or any kind of budget to give to nonprofits, I don't usually get involved in nonprofit activities, but a major organization is putting together a speaking tour with me next year. It's a campus speaking tour. It's going to have 8 separate events. I won't go into the details here because some of them are confidential. I'll tell you more if you contact me, but basically it's going to be a really big opportunity to reach a lot of people. I'm going to be speaking at a discounted rate. If you want to make a tax deductible contribution to it at the it's a pretty big thing. So we're talking about the $10,000 or more level. Just contact me, alex@alexepstein.com, and I will put you in touch with the people. So thanks to the people who've been interested in that already. Maybe we'll get a couple more. All right. Just want to stress again, energytalkingpoints.com, energytalkingpointsondemand.com. I can't share with you, a lot of the stuff that's going on is confidential, but you for sure are going to be seeing it appear even next year, some of this influence. We've got great people on the calls, great elected officials every week, great staff members. People are loving this. So just spread the word and you can make a great impact. Even if you don't know your congressman or senator, if they're pro-energy, pro-freedom, just tell them get your butt to energytalkingpointsondemand.com, get someone on our call, and that'll make a huge difference. All right. That is it for this week. I'll be back next week with Professor Bejan. Until then, I'm Alex Epstein. This has been Power Hour.
Power Hour. Life, liberty, and the pursuit of energy. Power Hour. The antidote to shallow thinking about energy issues.